Hi guys, so these are do it together notes, but I'm not together with you, so I'm doing a video so you can watch the video and do it in class. Alright, so this is Finding a Place to Live Part 2. Today we're going to be solving some word problems involving linear equations and systems of equations, and the word problems, as you might imagine, are going to be focused on moving costs, things related to finding a place to live, moving into a place. So it said you're going to have to look up vocab, but I'm going to give you this vocab. A linear equation is any equation with two variables that describes a straight line. So this line here could be described with a linear equation. Given a linear equation like 2x plus 3y equals 10, there are an infinite number of solutions to the problem. So these arrows on the end here, they go on forever and ever and ever. So that means there are ordered pairs assigned to every infinite point on this line. So for every x value you put in here to the input of x, you could solve for y, and you said output for y. So remember, x and y are coordinates of a point on the coordinate plane. We graph things to get a better idea of what it looks like. So graphing things is sometimes a visual presentation of a real life situation. Very often a real life situation, when it is graphed, is only going to occur, we're only going to look at the pertinent values in this quadrant 1, positive inputs and positive outputs. Sometimes that will change, but the majority of real world problems are going to fall into this quadrant 1. The line describes every pair of values when the equation is true. So any point on this line, if you plug in the x coordinate into this equation and solve for y, you would get the y coordinate. A system of equations is any pair or more. You could have 3 or 4 equations. We're only going to work with a pair of equations at the same time. So basically, if you can't recall from algebra or geometry, a system of equations is any two lines graphed on the same coordinate plane. For our purposes, 2 lines. The x value and the y value, or the x coordinate and the y coordinate, represent the same numbers or the same values on the coordinate plane. So if you have 2 lines graphed on a coordinate plane in the system, if they're graphed if their graphs never touch, that means their lines are parallel, then we'd have no solution. So that would look like something like this. So if we had a line parallel, that means there is no solution. So the solution of a system of equations is anywhere these 2 lines intersect, or the 2 lines in the system intersect, or the 2 points. Sometimes there's no points where they intersect here. You can see these have the same slope, they're parallel, they're never going to intersect. If the graphs touch always, then they're actually the same line. Oh, I can't get it to move. If all points touch, that means one is graphed on top of the other, and that means all their points are equivalent. And if that happens, there's an infinite number of solutions, infinitely many. That means every point on that line is a solution to both equations. And if the graphs only touch once, and that would look something like this, then the solution to this system of equations is this point here where they intersect at 2, 2. So a system that intersects in one point has one solution. Okay. To solve a system of linear equations, the first thing we're going to do is we're looking for, so these are all 3 systems of equations. 1 example, 2 examples, 3 examples of a system of equations, the same variable, 2 different equations. X, Y, X, Y, X, Y, and all of them. Now, this is one system. This is another system. This is a separate system. They're not all part of the same system. in order, so the solution to this system of linear equations, for example, this first one, would be the value for x and y that makes both equations true. So it's a point that makes both equations true, or if there is no point, algebraically we can find that. If there's an infinitely many number of points where they intersect, algebraically we can find that. So we are going to use the strategy of elimination to solve this system of equations. When you are in algebra and geometry, algebra in particular, you learn to solve by graphing, which is a terrible way to do it. You learn to solve by substitution, which is not a bad way. And the third strategy we learned in algebra was to solve by elimination. So we're going to be eliminating one of the variables and then plugging in for another. So how are we going to do that? Well, we're going to multiply one or both of these equations so we can stack the equations, add them together, and eliminate a variable. So multiply as necessary to stack opposite partners, and that's something like if one has a term 6x, if we can get the x term in the other equation to be equal to negative 6x, when we stack those or add them, we could eliminate the x's. So if we get opposite signs, and that means opposite partners means opposite signs, positive and negative, exactly the same except one's positive, one's negative, so they add to 0. We're going to add to stack to eliminate partners and leave one variable. We're going to solve for that variable. Then we're going to plug that value back in for whichever variable we solve for, and either of the equations, and I always use the simplest looking one, and solve for the other ordered pair. So we're going to start with this first example here, and if I'm looking at 2x and 3x, 3y and y, I want to know, can I just add these together vertically? If all the like terms are lined up, if I add these together, could I eliminate an x or a y? I cannot. So what we could do is we could look at these equations and see, is there something I can multiply one of these equations by where that when I do add them together, it would eliminate a variable. So remember, you can, when you work with equations, as long as you add or do the same thing to every term in the equation, then you can do whatever you want. You can change that form of that equation. So looking here, I'm going to see that, this is the 3y. If I multiply this by negative 3, I'll have a negative 3y. So my partners would be 3y and negative 3y. So that's what I'm going to do. I'm going to multiply this whole equation by negative 3, and then I'm going to add them together. So I'm going to take this 2x plus 3y. So the first equation I'm not doing anything with, and now I'm multiplying the negative 3y by everything in the equation. The one thing that kids forget, they forget to do the other side of the equal sign, so don't forget. And now we're going to add it together. When I add these together, I get negative 7x. When I add those together, I get 0. When I add these together, I get negative 14. And now I have negative 7x equals negative 14. I can solve for x. When I get to this point, I know that I'm going to have one solution because I'm going to be able to solve for this x. If you have no solution or infinitely many, those are special solutions, and it looks different from here. But once we get to here, if we have a value for either coordinate, then now we know there's one solution to this system, and it's 1 point. It's an ordered pair. So the x-coordinate is 2 here. To find the y-coordinate, I'm going to take that 2, and I'm going to plug back into either equation and solve for y. I'm going to plug back into the same equation because y is all by itself there, so that one looks easier to me. So I'm going to take, I'm going to plug the x in here, and then I've got y by itself. I just have to solve for that. So it's going to be 3 times 2 plus y equals 8. That's 6 plus y equals 8. I subtract 6 from both sides to solve that equation. Now I know that y is 2. So my y coordinate is 2, and that is the solution to this system. I'm going to go at a pretty quick clip here now. Remember, you guys can pause to catch up with me and go at your own pace. Looking at these next two equations in this system, I see there's an 8y here and a 16y here. What I'm looking for is I'm looking for one equation that I can multiply by a factor and then eliminate a variable. Sometimes we can't do that. Sometimes you have to multiply both equations by a factor. But looking here, I can see 8y times negative 2 would give me negative 16y. So then I could have these opposites of negative 16y and 16y to eliminate the y's. So that's what I'm going to do. I'm going to multiply this whole equation by negative 2. So I'll have negative 20x minus 16y equals negative 404. And I'm not doing anything to this equation. I'm just bringing it down. And solving for not x, but solving for y. Negative 20x plus 12x, negative 8x. Those are eliminated. Equals negative 104. 104 divided by 8. Negative 104 divided by negative 8 would give me positive 13. So now I know I have one solution. If I can solve for one of the variables, I know there's one solution now. So that is my x-coordinate. I'm going to take my y-coordinate and plug into either one. Once again, I'm going to plug into that top one. It looks the easiest. So 10 times 13 plus 8 times y equals 202. I can do this math in my head. 130 plus 8y equals 202. I'm going to subtract 130 from both sides. And I have 8y equals 672, but yeah, 72. So if I divide both sides by 8, now I know my y coordinate is 9. Okay. Looking here at this third example, I'm whipping through. This is similar again. If I multiply this, so there's nothing that I can easily multiply either of these by. 3 times 2 doesn't give me 7. 3 times 3 doesn't give me 7. But here I see these are multiples. These have a common factor. They're multiples. 5 times 2 would give me 10. So I'm going to use 5y times negative 2 to get my partners negative 10y and 10y. Positive 10y is here. So if I multiply this whole equation by negative 2, I'm going to be able to eliminate those y's. So I'm going to bring down my first equation, 7x plus 10y. I'm not doing anything with it right now. And now I'm multiplying all my terms here and rewriting it. Oh, that's 68, not 78. Okay. Now when it adds them together, the y's go away. It gives me x equals 8. So once again, I know I have one solution because if I'm able to solve for one of the coordinates, now I know there is a solution. There's exactly one solution, and I have that coordinate. So I'm going to put that in my ordered pair. And then I'm going to use that x value in one of the equations and solve for y. So once again, I'm going to use the second one. It doesn't matter. I seem to be picking the second one all the time because it just, well, this one looks simpler. But I guess I picked the first one there. So maybe I'm not doing it every time. Okay. 3 times our x coordinate of 8 plus 5 times y equals 84. So I plugged into that original equation. So I subtract 24 from both sides. Now I have 5y equals 60. I divide both sides by 5. Now I have y equals 12. And I took some shortcuts there, but okay. So these are the solutions. There's exactly one solution for those. All right, we're kind of hopping around here. This is not the system of equations problem, but this is a real world problem. There are fees associated with moving into a new place. It says these movers charge $95 per hour for loading and unloading services, and they charge $80 per hour for packing and unpacking services. Their charge is $2.50 per mile for truck rental. So we've got to pay some amount for loading and unloading, some amount for packing and unpacking, and some amount for the truck rental. It tells you here that Jay is moving a distance of 200 miles, and he needs 9 hours of loading and unloading. That would be at $95 per hour, and 7 hours of packing and unpacking. So we have to find his moving cost, and he's got to pay a 7.25% tax on everything. So we're going to start with computing some of these costs. So we said he's going to have to work, pay for 9 hours of loading and unloading. That's at $95 an hour, plus 7 hours of packing and unpacking, and that's at $80 per hour, plus $2.50 per mile for truck rental, and he's going 200 miles. So that's 200 miles times $2.50. And so that would be a total for packing, unpacking, and the truck rental of $1,915. Now, that's not everything he has to pay for. He's also got to pay tax on this. So we take the tax that we're going to figure out a little shortcut way to find the tax. So we're going to use this little shortcut. 100%, so he's got to pay the $1,915. That represents 100%, right? So this is 100% of his moving cost, plus 7.25% more, right? So that's times his subtotal of $1,915. So that would be 107.25%, but we're going to use a decimal version. Remember, divide by 100. So we can multiply his subtotal here by 1.0725, and that will give us the total with tax included. So this is his total amount including tax to move with new home movers. Remember, you can pause if you need to catch up. We move you charges. They give us in a little different formatting. Loading and unloading, packing and unpacking, and then truck rental per mile. We see that Nikki is moving a distance of 150 miles, and we see that it's $5 per mile. She needs 7 hours of loading and unloading. Well, that's $85 per hour, right? And finally, she needs 5 hours of packing and unpacking here. So we're going to do like we did the last example, 7 hours of loading and unloading. So 7 hours at $85 an hour, plus 5 hours at $70 an hour for packing and unpacking, plus 150 miles at $5 per mile. So that gives him a subtotal of $1,695. Now to find the total including tax, remember it's going to be 100% plus 8%, which is 108%. And we're going to use a decimal version of that, but honestly with our calculators, you could use a percent symbol. So it's 1.08 times the subtotal, and for a a grand total moving expenses $1,830.60. Remember, you can pause. All right, my moving company gave Mike 2 quotes. Determine the hourly rates for loading and unloading and packing and unpacking. So now we're writing a system of equations, which means we're writing 2 equations. We're going to use X to represent the number of, the hourly rate for loading and unloading. We're going to use Y to represent the hourly rate for packing and unpacking. We don't have a per mile cost here. We're only responsible for writing and solving system equations with 2 variables. So we're only going to have 2 different variables. So if we want to start with this first quote, 3 hours of loading and unloading, so that would be 3 times X, right? Plus 2 hours of packing and unpacking, so 2 times Y equals a total cost of $480, right? So that is our first equation in our system. So this equation, 5 hours of loading and unloading, so 5X plus 2 hours of packing and unpacking again equals $680. So we're trying to figure out the hourly rate for loading and unloading and packing and unpacking. So we're going to go ahead and write our other equation here. Don't really need to have it twice. All right, once we have a system, now we can use the strategy we just used. This is convenient because I can see here they're both 2's. So I need the opposite of that, which would be -2 or 2y. So if I multiply this one by -1, that makes that -2y, then I can just add them together. So that's what I'm going to do. 3x plus 2y equals 480, and I'm going to multiply all of these by -1. -5x minus 2y equals -680. And add them together. And I'm going to divide both by -2, and so the hourly rate for loading and unloading is $100, right? So that is, so this is a situation we don't give our answer as an ordered pair, right? We are going to give our answer as, it's $100 per hour for loading and unloading, and I'm abbreviating that as loading and unloading. All right, but I still need this to solve for my hourly rate for packing and unpacking, so that means I'm going to plug in 100 for X in one of these, and I'm just going to use this first one. 3 times 100 plus 2y equals 480. I'm going to simplify and start solving. Subtract 300 from both sides. Divide both sides by 2. And now we know that the charge for hourly rate for packing and unpacking is $90 per hour for packing and unpacking. And I'm just going to abbreviate that P/U. Okay, remember you can pause if you need to catch up. All right, example 4. I've been charged an hourly rate for a moving team to load and unload a truck that charges a different hourly rate for a team pack and unpack boxes. Use the quotes below to determine the IVAN hourly rates. So a weekday move versus a weekend move. Okay. So we're looking for the hourly rates. So here we're still using X for loading and unloading, hourly rate for unloading and loading, and Y for the hourly rate for packing and unpacking. All right, so our first equation is going to be based on the weekday move. So it's going to be 8X plus 6Y equals $890. So 8X plus y equals $890. So for a weekend move, so we have our first equation in our system. For our weekend move, 5 times the hourly rate for loading and unloading, plus 3 times y, the rate for packing and unpacking, and it equals 515. And now we're doing the same thing, looking for something that we could easily multiply, preferably one of the equations by, to get a pair of opposites. Our opposites are going to be, this is a 6y. I can see that if I multiply 3y by negative 2, then I can get my opposite negative 6y. So that's what I'm going to do here. Now I'm going to add them together. I'm going to bring down that first equation first. And then I'm going to multiply the second equation. And now I'm going to add them together. And when I do, you'll see my y's are eliminated. And so I have negative 2x equals 140. Oh, I forgot to put my negatives down here. You see that that's negative 140. I divide both sides by negative 2. And so my hourly rate for loading and unloading is $70. So it's $70 per hour for loading and unloading. Now to find my hourly rate for packing and unpacking, I plug that x in and solve for y. I'm going to do this second one. It's with smaller numbers. I might be able to do in my head. So 5 times 70 plus 3 times y equals 515. So I'm plugging in for here. So that's 350 plus 3y equals 515. Subtracting 350 from both sides, I get 165. So 3y equals 165. Now the y by itself, I divide by 3 and I see that y is 55. And in this real world problem, that means that it's $55 per hour to pack and unpack if we use I-van movers. Remember to catch up, just pause it. Okay, example 5, I think we've got 2 more. Example 5, Samantha's moving from Madison, Wisconsin to La Crosse, Wisconsin. She will do all the packing and unpacking by herself. The moving company quoted a price of $1,250 for 8 hours of loading and unloading and driving 130 miles. The company quoted the same price if the truck drives an extra 30 miles to pick up Samantha's brother. She figures that with her brother's help, she only needs to hire the movers for 6 hours. How much does the company charge per hour for loading and unloading, and how much do they charge per mile for driving? Okay. So we're going to use X, the hourly rate for loading and unloading, and Y for the mileage charge. Okay. So our first equation, hourly rate for loading in. So they're doing all the packing and unpacking. So we're adjusting here. So there's 8 hours of loading and unloading, and they're driving 130 miles. So that's going to be 8x and 130y, and that's going to equal $1,250. So that's the first equation in our system. Now, the next equation, they tell us the company quoted the same price, so it's that same $1,250, if the truck drives an extra 30 miles, so that would be 160 miles, right? 30 plus 130 is 160 miles for our second equation. But she'll only need the movers for 6 hours. So instead of 8 hours for X, that would be 6 hours for X. Okay? So the price is the same, but it'll be 30 more miles at the mileage charge and 2 less hours for the unpacking, or the unloading rather. Okay, so now we're going to look at these two coefficients on either x or y and see what can we easily multiply one of the equations by so we can get our opposite coefficients. But there's not anything that we can easily, we want to multiply, the easiest thing to do is multiply by a whole number. So if we can't multiply, there's not a number, an easy number to multiply 8 by to get 6 or 6 by to get 8, right? So I could multiply both equations by number and get opposites that way. So I'm looking here, I see 8 and 6 are both factors of 24, right? So 3 times 8 is 24, and 4 times 6 is 24, but I do need opposites. So if I do negative 4, I'd have a negative 24, and I'd have my opposite pair. So that's what I'm going to do. Multiply this first equation by 3, because that'll give me 24x, and multiply the second equation by negative 4, because that will give me negative 24x. So now I'm going to rewrite. That equals 3750, and now I'm multiplying negative 4 by everything in the other one, so negative 24x minus 640y equals $5,000. But not 5,000, it's negative 5,000. That will trip you up if you forget your negatives there. Alright, so now when I add them together, my x's are eliminated. And so now I'm looking to see 390 minus 640, or plus negative 640. Can't seem to use the calculator. Alright, so negative 250y equals negative 1250. Divide both sides by 250, and I have y equals 5. So y stands for the mileage charge, so it's $5 per mile. Okay? Now we're going to use that mileage charge, that y value in one of these equations to find the hourly rate for unloading and loading. So I'm going to use the smaller one numbers, it doesn't really matter. 6x plus 160 times our y of 5 equals 1,250. So 6x plus 800 equals 1,250. I'm going to subtract 800 from both sides, and I get 450. I'm going to divide both sides by, let's see, 450 divided by 6 is 75. Divide both sides by 6, so x equals 75. But remember, that's the hourly rate for loading and unloading, so it's $75 per hour for loading and unloading. All right, well, we can pause to catch up with me. Last but not least, number 6. There's 2 estimates in this little box here that Jaden received from a moving company, and he wants to determine the hourly loading and unloading fees and the mileage charge. like we just did in the last example. So we have to state what our variables represent, and I've been putting it up here, but I didn't talk about it. So we have to state what the x stands for, what the y stands for, and then we write our equations. So it only makes sense if we know what x stands for and y stands for. Alright, so situation A, he needs 5 helpers to load and unload, right? So that's 5x. And he travels 80 miles on back roads, 80 miles, so that's 80y. And we know it equals $780. So that's our first equation. The second equation, he hires 6 helpers to load and unload, so that's 6x. And it takes a highway route which adds 20 miles, so it's 80 plus 20, so don't get confused, that's 100y, and that's going to equal $960. I have a typo on my problem, my equation there. Okay. So now I'm looking to see, all right, how am I going to solve this system of equations? I need, ideally, a number I can multiply one equation by to eliminate a variable, but there is not such a thing, not an integer anyway. But I see these are both factors of 30. So if I could find something to multiply 1 by to get 30x and 1 by to get negative 30x, that's what I want to do. And of course I can do that. So 5 times 6 is 30x, and 6 times negative 5 is negative 30x. So that's what I'm going to do. I'm going to distribute that 6 to the first equation. I almost made the mistake that some kids do. I multiplied here, but I forgot there. So that's 480y equals 6 times 780, which is 4,680. Now I'm going to do the same thing with the second equation. Now I'll see, got my pair, my opposite pairs there that they're going to add to 0. Minus 500y equals negative 4,800. Those add to 0. This adds to negative 20y. And this equals negative 120. If I divide both sides by negative 20, I'll see that y equals 6, positive 6. Y is my mileage charge, so $6 per mile. Now, to find my hourly rate for loading and unloading, I plug that 6 back into one of these equations. Doesn't matter which one. I'm going to plug it into the first one. 5x plus 80 times 6, because our y is 6. It's a very squiggly thing. 80 times 6 equals 780 times 6, or 4680. And now I'm going to, I'm still just simplifying here. 5x equals 480 equals 4680. I'm going to subtract. I got way too many equal signs there. Right, that one's not an equal sign. That is a plus. 5x plus 480 equals 4680. I'm going to subtract 480 from both sides. Now I know that 5 times x equals 4,200. Now I'm going to divide both sides by 5. And I know that I've done something wrong. What did I do wrong? Side x 80. Oh. Where did I get 4680? I think I multiplied something. Oh. I copied this wrong. Maybe. Dang, if I was going to make it through the whole video without messing something up. Huh. Not. Okay, it's alright. So, one more time, I'm just going to start this over so I'm less confusing maybe. Alright, so our mileage charge of $6 per mile is correct. We're going to use that mileage charge in place of y in this first equation. So 5x plus 80 times 6, that's where the y is, and now we know this is the y value, equals 780. So now we're simplifying. And we're subtracting 480 from both sides. So 5x equals 300. And we're dividing both sides by 5, so x equals 60. And it's an hourly rate, so it's $60 per hour for loading and unloading. So the word problems you won't get the answer as an ordered pair. You label them according to what those variables represent. Okay, I will see you guys soon. Take care.